We've had to put the object tracking robot on pause for just a couple of days because the motors are crap. The motors are crap. They're trying, but they're little toys. The object tracking robot, it triggers properly. When I put this on a little jack stand, the motors trigger the way that they're supposed to based off of when it detects an object. It's got it a little heavy at this point, and trying to move all this around on crappy little plastic motors isn't working out so well. So anyways, we have new motors coming in from Adafruit, so hopefully next week we'll be able to make that a little bit more solid. So I went to the hobby store today because there's like an RC hobby store around here, radio control hobby store, and I just kind of want to see what motors and stuff they had, and oh my God, RC cars are expensive. I didn't realize RC was quite such an expensive hobby. So I did not buy an RC vehicle, but I did buy a $5 little foam plane. And so one of the things, if you've followed me for any length of time, you know I've been thinking about those autonomous aerial vehicles for a while, and basically the concept of can you create a very inexpensive autonomous aerial vehicle for things like deliveries. When you need to deliver a grapefruit. Anyways. Unfortunately, the world has gotten the world has gotten to what it's gotten to over the past year or so. So anyways, again, I've been curious about that. Essentially, can you create very low-cost autonomous vehicles? Again, that whole idea of what happens when high tech becomes disposable, right? You think about an autonomous vehicle, you think about a Predator drone or some cargo aircraft or whatever that costs hundreds of thousands or millions of dollars, right? When a product costs hundreds of thousands or millions of dollars, you are going to use it in a particular way. My question is what if you can make autonomous drones that cost $20, right? What if you can make an autonomous drone for $20 or $30 and figure out a use case for that? How does that change what you would use that type of thing for? So anyways, want to play around with that. So this is our little $5 thing, which actually, I do have to say, for a $5 styrofoam plane, it's pretty solid there. From Hobbytown, I give them a thumbs up. So I bought that from Hobbytown, and what I'm looking at here is, so this is a GPS unit. So actually, this right here is the GPS unit. For a good one, it'll cost you $30 to $40. This is the antenna for this particular unit. So this gives you your GPS coordinates. It actually does it pretty well. So it gives you your lat, your long. It also gives you your elevation, and it gives you your speed. Which is some interesting stuff. And it's all in this pretty small package. I actually have a different GPS unit. I have to find it somewhere over there. That actually has an internal antenna. So you don't even need this big old thing along. You can just have this one little GPS module essentially super glued to it. Then you have the Arduino. So Arduinos, again, if you get the real Arduino, it costs you like $40. If you get fake Arduinos, it costs you about $5. So you have the Arduino. And then we have motors. So these are actually drone motors. You can buy drone motors from Amazon. Buy them by the dozen, because that's how you buy everything from Amazon. When you buy the drone motors, you can buy propellers. And so what I was working on here is, this is kind of interesting, is basically, if I set this up properly. Let me do this so I don't hurt myself. Can I do this so I don't hurt myself? So what I've done is I've connected the drone motors here directly to the 3.3 volt on the Arduino. So I don't necessarily need an H-bridge. So an H-bridge is another module. Again, the more weight you put on a device or put on an airplane, the harder it's going to be to get in the air. So I can just plug straight into 3.3 volts and then plug that into a USB. And so what's cool here with this is, so I have a USB battery pack that is powering the Arduino. So the Arduino can then power the GPS unit, and it can power the motors here. And the motors really do give, if you see, that's kind of hard to see, but if I have this pivoted, you can see that the motors are they actually do have enough force, at least to move something forward. We'll see how that works in the real world. And so, yeah, so that will be the basic idea. GPS unit goes in the Arduino. Arduino connects to the motors. So you can use something called pulse width modulation. So in order to make the airplane go up, basically you increase the speed of the motors. To have it go down, you just decrease the speed of the motors. To have it turn, you turn on one motor and turn off one motor, and that will get it to turn. And so basically with all of that, we should be able to have an autonomous vehicle that can deliver a grapefruit and, I don't know, for, probably $30, $40. So this whole thing, when it gets done, because I'm using so this is actually probably the Arduino board that I'll use. So I don't know, this is an official Arduino board. Again, you gotta think about weight and size. So this is the official Arduino board. Burpee. This costs about $40. The GPS unit, good GPS unit, also costs about $40. The motors and everything else aren't too much. So this whole thing, when it gets done by me, will cost about $100 for that prototype unit. But again, like I say, you can get Arduinos, and you don't even have to get Arduino. You could actually just get the IC chip if you really wanted to. But you can get knockoff Arduinos for like $5 a piece. GPSs, you could definitely get a hell of a lot less expensive. And I think you could get this as an autonomous vehicle, I do believe, for about $40 a pop. Then the question past that is like how much weight can this handle? So how much weight can it handle? And then with whatever battery pack, the I&E battery packs, whatever battery pack you give it, how far it could go. So what if you had a $40 autonomous drone that was able to go 10 miles. Again, let's not do stupid. Let's not do 100 or 200 miles. If you could simply launch something of this size, what could you put in here? You could put in antibiotics into here. If it could go 10 miles, maybe you could put a camera onto it to take pictures at specific GPS locations and then relay that back to you. Those are some things to think about. The next iteration of this, that I'll get to at some point, so I'm getting a lot of projects, is if we can get this moving by GPS, then the other interesting thing is if I can double the size of this, so you can see how big this is, about 2 hand spans, right? So if we can double the size of this, we would get a lot more space in there. If we had a lot more space on this thing, we can actually use a Raspberry Pi instead of our Arduino. And the cool part with Raspberry Pi is Raspberry Pi can connect to GPS, but it can also have a camera. And so one of the things that I'd be interested in is could you build an autonomous drone like this for, let's say, sub $100 at this point, that would be able to geolocate, so get to a location based off of GPS signal, and then once it is at a location, could you trigger it to do something based off of visual cues? So imagine in a disaster scenario, right? A hurricane has come through or whatever else. Imagine if you could send, again, like antibiotics, something small, and that's all we're dealing with right now, but you could send this, it would go 10 miles or whatever else, it would see on the ground, maybe if there was a star, like so it gets to a location and then people unroll, let's say an orange tarp. So it sees, when it sees the orange tarp, release the antibiotics or whatever else so that people can get it down below. And again, the whole idea of, what if you can build that in your own garage for $100 or whatever. So anyways, that's what we're playing with. And this is what I really want folks to understand nowadays, is this is all damn near hobbyist level stuff. Like what I'm showing you with a lot of this stuff, literally a 9-year-old could do. Again, you're like, oh, GPS is complicated, this is complicated. But again, yes, GPS is complicated, right? Whoever designed this GPS unit, they were smart. They were so smart. Here's the thing, I don't care about that. I simply have to send information to it and then be able to parse the information that comes back. That's all I need to do. GPS is hard. Parsing text is not, right? And that's the amazing part about all of this is the code and so much of what's required, literally anybody can do at this point. And the funny part is just simply a lot of people don't realize it. So anyways, that is what I am working on. If you like these types of videos, give us a thumbs up. If you don't like these types of videos, give us a thumbs up. Share, subscribe, do all that kind of fancy stuff. and I'll see y'all later.